back, students. In this class we are going to learn how to describe the structure of rock salt, and there are many observed questions which is very important from it. Okay, so do remember, rock salt means sodium chloride. You know that sodium chloride is also known by the name common salt. Sodium chloride is also known by the name common salt, and its another name is rock salt. Okay, now before we describe the structure of rock salt, you should know the location of sodium chloride inside a rock salt. So do remember, in rock salt, sodium ions are present in edges, and it is even present in body center. It is present in body center. Whereas chloride ions are present in corners and in face center. So do not forget this, students. The location of sodium ion inside rock salt is in edges and body center, and the location of chlorine is in corner and in face center. And do remember, student, the size of cation is smaller, so I am representing with this sign, whereas the sign of anion is larger. You have learned in class 11 the size of cation is always smaller than its atom, whereas the size of anion is larger than its atom. So here I am representing sodium with your shaded dot, small one, and chloride with the big circle. Okay, it's because the size of anion is larger than that of sodium. So let us consider the sodium which is in the edges by black dot, and the sodium which is present in the body center by the red dot. And since chloride ions are present in the corner and the face center, which I am both representing with capital dot. Now let us make its picture. So you know that since in our syllabus we have only cubic structure in our syllabus, so I am about to make a cube for you all. And let us see the location now. As I have said you, sodium ions are present in the edges. And there are actually how many edges in a cube? 12. And what does edges mean? The midpoint of a length. So this is a midpoint, this is the midpoint of a length. This is the length, midpoint is here. This is the length, this is the midpoint. This is the length, this is the midpoint. So you can see the 4 edges. Now let us make it for the down one. This is the length, so this is the midpoint, this is the length, this is the midpoint. This is the length, this is the midpoint, this is the length, this will be the midpoint. So if you can see, the edges which I made in the upper surface is 4 and in the down is 4. 4 plus 4 makes it 8. Now this vertical line, the midpoint is here, which makes it 9. With this midpoint of this vertical line makes it 10. With this vertical line midpoint it makes it 11. And with this vertical line midpoint it makes it 12. So do remember, students, sodium is present in 12 edges. So I made that 12 edges for you. And one sodium ion is exactly present in the center of the cubic unit cell, which I am representing with the red color. Okay, this body center which is red one, all are black, which is in the edges. Now where chlorine are present? Chlorine are present in the corners. And how many corners are there in a cube? 8. So 1 corner, 2 corner, 3 corner, 4 corner, 5 corner, 6 corner, 7 corner, 8 corner. What is present? Chloride ions are present in the 8 corners, 4 up, 4 down. Now how many faces are there in a cube? 6 faces. And in the center of the faces also what is present? Chloride ion. So for upper face this is the center. For down face this is the center. For right face this is the center. For left face this is the center. For the back face, suppose let us consider this as the center, and the front face let us consider this as the center. For front face, okay. So this is the location of chloride ions, students. So now you can see here that sodium are present in the edges, means the midpoint of a length, and in the body center, and chlorine are present in the 8 corners and in the 6 faces, center faces. Now here we have to calculate what is the number of sodium ion and what is the number of chloride ion per unit cell, and even what is the number of NaCl present per unit cell. For that we do the calculation here. So number of sodium ions present per unit cell. So to do the calculation of number of sodium ion present per unit cell, you have to remember that where are the sodium ion present? Sodium ions are present in the edges, and it is present in the body center. And always remember, in corner we share the particle will share 1/8 part of it. In face center the half, and in edges is shares is 1/4. and body center is the middle one, which is not shared with anyone, so it is only solely mean for this cubic unit cell, so it will into 1. Now how many edges are there in a cube? 12, and body center is one piece, only shared for the only one cubic unit cell, so it will be 1. So if you solve this, it will come 3. 12 divided by 4 is 3, and 1 into 1 is 1, so is equals to 4 chloride ions. So 4 sodium ions. So do remember, in a crystal lattice of NaCl, there are 4 sodium ions present per unit cell, students. Now similarly, let us see what is the number of chloride ion present. So here I am writing, here is the number of chloride ions present per unit cell. Now let us see the number of chloride ions present per unit cell. Where are the chloride ions present? You can see from here. Chloride ions are present in corner, and it is present in face center. Chloride ion is present in what, students? In corner and in face center. Corner will always share how much part of the particle? 1/8. And the face center will share half. Now how many corners are there? As you know, there are 8 corners, and how many faces are there? 6 into half. So if you solve this, it will come 1 plus, if you solve this, it will come 3 is equals to 4 sodium ions, 4 chloride ions. So do remember, students, in a crystal lattice of NaCl, 4 sodium ions are present in per unit cell, and 4 chloride ions are present per unit cell in NaCl. Therefore, total number of NaCl present per unit cell. Now we are going to find the total number of sodium ion present per unit cell. So what we are going to find, students, now is total number of sodium ion present per unit cell. So do remember, students, in the total number of sodium ion present per unit cell is how many? 4, which I am writing from here. And the total number of chloride ion present per unit cell is how many again? 4, which I am writing from here. So what is the total number of NaCl present per unit cell? So 1 Na plus will combine with 1 Cl minus to give you 1 NaCl. 2 Na plus will combine with 2 Cl minus to form 2 NaCl. 3 Na plus will combine with 3 NaCl to form 3 NaCl. So similarly, 4 Na plus will combine with 4 Cl minus to give you 4 NaCl. So do remember from here, students, that number of sodium ion present, NaCl present per unit cell is again 4, because there are 4 sodium ion, 4 chloride ion. So what happens, students? 1 sodium ion will combine with another chloride ion to give you 1 NaCl. 2 Na plus will combine with 2 Cl to give you 2 NaCl. 3 Na plus will combine with 3 Cl to give you 3 NaCl. So similarly, 4 Na plus will combine with 4 Cl to give you 4 NaCl. So do remember, students, the location of sodium in a structure of a rock salt is in edges and body center, whereas your chlorine is present in face and the corners and face. Okay, so if you calculate, the number of sodium ion per unit cell will also come 4. The number of chloride ion present per unit cell will also come 4. So similarly, the total number of NaCl present per unit cell will come 4. And since the total number of NaCl coming per unit cell is 4, means it has FCC structure. Because 1 means primitive cubic unit cell, 2 means body center, and 4 means face center. So what kind of unit cell rock salt has? So the answer is FCC. But you cannot write FCC in exam. You have to write face centered cubic unit cell. Face centered cubic unit cell you are going to write. Okay. So this is how we calculate the number of sodium ion, the number of chloride ion, and the total number of NaCl present per unit cell in the structure of rock salt. And do remember the locations. So now it's very easy to remember. Why? Because the number of sodium ion is also coming 4, the chloride ion is also coming 4, and your NaCl number is also coming 4. So you can say 4, 4, 4. Sodium ion number per unit cell 4. Chloride ion number present per unit cell is 4. Number of NaCl present per unit cell is again 4. So all are 4, isn't it? So here some students make mistake. What they do out here is like this. Who is actually in edges and body center? Sodium ion. But they write here chloride ion. Who is present actually in corner and face center? Chloride. But they write sodium ion. And if they do so, the number of chloride ion will again come 4, and the number of sodium ion will also come 4. As a result, the number of NaCl will also come 4 plus 4. 4 plus 4 is equals to for NaCl. And once they come out of the exam hall, what they say, oh, the answer was so easy, all was 4 for 4, I got it. But students, do remember, that particular student has made one mistake. All are supposed to come 4 and he got 4 or she got 4, but the problem is they made some wrong. Because actually sodium chloride is not present in ages and body center. Who is present here? Sodium. But the person wrote is what? Sodium chloride. So similarly, who was supposed to be in chlorine corner and face center? Chlorine. But what the person wrote is sodium. So it's wrong. So do remember, student, who is present in the ages and body center? Sodium. And who is present in your corner and face center? It's chloride. So all will come 4, but you may miss the location. So this is how you remember from today then. Okay. Since NaCl has FCC structure, because all are coming 4, so you will remember this 4. Okay, and you will write FCC. But from today onwards, the full form of FCC is different from today. So what is the meaning of FCC here? Let's check here. Okay, for us, NaCl has FCC structure, everyone knows. But what is the meaning of FCC for today? Only for this topic. Do remember, F means face, C means corner, another C means chlorine. So you can remember this way, face, corner, chlorine is present. Actually the full form of FCC is different, but for this particular topic, remember that NaCl has FCC structure. You will remember. Why? Because all is coming 4, 4, 4. But to remember the location, do remember for this particular topic, FCC means face, corner, chlorine is present. What is the meaning of F? Face, C, corner, C, chlorine is present. So face, corner, chlorine is present. So what are the remaining places we have? That is ages and body center. So if face, corner, chlorine is present because of FCC, you have to remember that way. Then what are the remaining places? Ages and body center. So in ages and body center, who will be present? Sodium. Okay, that is how you can remember, students. Now do remember, students, in crystal of NaCl, it is not possible to show in this diagram. You can refer the book for it. But right now I am giving you a rough idea here. Do remember, in crystal of NaCl, one sodium ion is surrounded by 6 chloride ion. One sodium ion is surrounded by 6 chloride ion. Similarly, one chloride ion will be surrounded by 6 sodium ion. One chloride ion will be surrounded by your 6 sodium ion. So this also they may ask you. So do remember, students, one sodium ion is surrounded by how many chloride ion? 6. Similarly, one chloride ion is surrounded by how many sodium ion? 6. So since one sodium is surrounded by 6 chloride ion, so the coordination number of sodium ion with respect to chloride ion is 6 because it is surrounded by 6. Similarly, the coordination number of one chloride ion which is surrounded by 6 sodium ion is again 6 because one chloride is surrounded by 6. So if the coordination number of one sodium ion with respect to chloride is 6, similarly coordination number of one chloride ion with respect to sodium is again 6. Therefore, we can say that those who have coordination number 6, they have what kind of arrangement? They have octahedral arrangement. So they have octahedral arrangement. Okay. So do remember, sodium ion has what kind of arrangement? Octahedral arrangement, students. Now let us go with the questions and answers from your NaCl. This has come so many times in your board exam, students, and usually the objective question comes. But this much you need to remember for it. So do remember the location of sodium ion and chloride ion inside NaCl, and how to calculate the number of sodium ion and chloride ion, and even the total number of sodium ion, and what is the coordination number for sodium ion and chloride ion, and what kind of arrangement they have. Okay. Now I am going to go with the question and answer round. You can play it back to make the notes. Okay. So number 1. So in the structure of NaCl, where is the location of sodium ion and chloride ion? So do remember, what is the meaning of FCC? Face, corner, chlorine is present. So the location of chloride ion is in face, center and in corners. Then what will be the location of sodium ion? Sodium ion location will be ages and body center, students. So do remember the location. Number 2, they may ask you, in what type of units lattice it crystallized? In what type of lattice is crystallized? So answer is face centered cubic unit cell, that is FCC. Or they may ask you what is the type of unit cell NaCl shows. So again the answer is FCC. Whether they say in which lattice it crystallized, answer is FCC. Whether they say the type of unit cell it has, so again the answer is FCC. And you should write down the full form in exam, that is face center cubic unit cell. After that they may ask you is what is the number of sodium ion per unit cell? So the answer is 4. What is the number of chloride ion per unit cell? Again the answer is 4. What is the total number of sodium ion present per unit cell? What is the total number of sodium chloride present per unit cell? Again the answer is 4. Okay, and do remember what type of solid is NaCl? It is a ionic solid. I repeat again, NaCl is an ionic solid. It comes under ionic solid, and the force of attraction which binds sodium ion and chloride ion in this is electrostatic force of attraction. So what type of solid NaCl is? So the answer is ionic solid. And what is the force operating between the two ions? So you have to say the force operating between Na plus and Cl minus is electrostatic force of attraction, students. Then they may ask you out here the coordination number. State the number of chloride ion. State the number of chloride ion which surrounds sodium ion. So the answer is 6. Similarly, they may ask you state the number of sodium ion which surrounds chloride ion. Again the answer is 6. So what is the coordination number of one sodium ion which is surrounded by chloride ion? Again the answer is 6. What is the number of coordination number of each sodium ion surrounded by each chloride ion surrounded by sodium ion? Again the answer is 6. And what kind of arrangement they show? The answer is octahedral arrangement. Why? Because the coordination number is 6. So I like to repeat this again. The number of sodium ion present per unit cell is 4, chloride ion present per unit cell is 4, NaCl per unit cell is again 4, because of which it has FCC structure. But the number of chloride ions surrounding the sodium ion is 6, and the number of sodium ions surrounding the chloride ion is again 6. So since one sodium is surrounded by 6 chloride ion, therefore the coordination number for each sodium ion is 6. Similarly, the coordination number for each chloride ion is again 6 because it is surrounded by 6 sodium ions. And do remember coordination number 6 means both of them has what kind of arrangement? Octahedral arrangement. So what is the type of arrangement? The answer is octahedral arrangement, students. And do remember FCC means face, corner, chlorine is present. Then what are the two remaining places? Edges and body center. In that what is present? Sodium ions are present, students. So if you want, you can take the screenshot of this. So whatever objective question just now I illustrated to you, remember that for the objective questions. And do remember sodium is an ionic solid, sodium chloride is an ionic solid, and the force of attraction which binds sodium ion and chloride ion out here is electrostatic force of attraction. Thank you very much.